Hi, welcome back to my YouTube channel. I am Moses Oluwasegun Alex, and this is Programmed Mathematics. Okay, in the last video, I explained the method of referring to elements of a matrix. Okay, and I gave an assignment which is still on the board here. That was in the previous video. Okay, you are given matrix P equals this, and you are given the elements of matrix P. So you have to find the value of x, y, m, and n. Right? So let's quickly look at the problem. If you have solved the question, so let's look at the problem together, and then you can cross-check your solution with mine. So quickly, before we move on to what we have to discuss today. So first, correction to this assignment. Correction to the assignment. Okay, so we have matrix P being equal to x minus 4y, x plus y, 2m minus n minus 2m. And we have the elements of matrix P. Remember, this also is the same as P11, P12, P21, and P22. So matrix P is a 2 by 2 matrix. Okay, having 2 rows and 2 columns. Now, we are given these values of P1, P11, P12, P21, and P22 already here. So we can write this as x minus 4y, x plus y, 2m minus n minus 2m equals, so P11 we have is 3, P12 is 7, P21 is 0, P22 is 4. Okay, so we have that. So now to solve this problem quickly, if you practice this question on your own, you would have noticed that the problem is actually going to lead you to simultaneous equation. Simultaneous equation starts from JSS 3. That's the junior secondary school 3. Okay, and for those that make use of years, that's talking about that is year 9. Okay, of some other schools. So in this case here, we have that x minus 4y in this case is the same as 3, x plus y is the same as 7, 2m minus m is the same as 0, n minus 2m is the same as 4. That's a simple illustration there. And so when you write down the first one, x minus 4y equals 3, and then also x plus y equals 7. This is a simultaneous equation in 2 variables. Simultaneous equation in 2 variables. So your method of elimination, substitution, comparing coefficient method, and every other one can be used to solve this problem. So for this, I'm going to make use of the simple elimination method, because I can see that in these 2 equations, I can call this equation 1, this equation 2. So in both equations, the coefficient of x is balanced already. So this is plus 1 here, plus 1 here. So 1 minus 1 gives 0. So that will get x out of this equation. So we are simply subtract equation 2 from equation 1. So if I'm going to subtract equation 2 from equation 1, the arrangement is done already. So I have x minus 4y equals 3 and x plus y equals 7. So if I'm subtracting this, my x minus x is 0, minus 4y minus plus y will mean minus 5y equals 3 minus 7 is minus 4. Don't forget what I said here. This is minus 4y minus plus y. Okay? Minus times plus is minus. So this minus 4y. Minus 4y minus 1y. This y here is having a coefficient of 1 there. So minus 4y minus 1y. Minus 4 minus 1 is minus 5. So together here, we are minus 5y. And of course, 3 minus 7 is minus 4. When you subtract a larger number from a smaller number, your result is always negative. So in this case, minus 5y equals minus 4. So we divide both sides by minus 5, minus 5. Minus 5 cancel from here. So y therefore will be equal to, so this minus cancel out from here also. y equals 4 over 5. So if y is equal to 4 over 5, I can make use of equation 2 to find the value of y. So I can say substitute, okay, substitute 4 over 5 for y in equation 2. And equation 2 is x plus y equals 7. I want to make use of equation 2 because it's very straightforward. Any of the equations can be used. If you decide to use equation 1, you get the same result for your x. So no rule says it has to be equation 1 or equation 2. Choice of equation is dependent on you, okay? So x plus y equals 7. Y now is 4 over 5. So this is x plus 4 over 5 equals 7. So x will be equal to 7 minus 4 over 5. Move this to the other side here. And if you subtract this, this here will simply be 6 whole number 1 over 5. Okay? 6 whole number 1 over 5. Remember, to do this, you can simply say 7 is the same thing as 6 plus 1 minus 4 over 5. When you subtract a proper fraction from a whole number, from 1, okay, simply subtract the numerator from the denominator. Whatever you get divided by the denominator. Okay, so 6 plus 5 minus 4 is 1 over 5. So we have x, we have y. Now let's go back to the matrix because we still need to find the value of m and n. Now also, we have that 2m minus n is the same as 0. 2m minus n, that's p21, p21. 2m minus n and 0, they are the same, equals 0. And as well, n minus 2m is equal to 4. n minus 2m here equals 4. Alright, so if we have to solve this equation as well, this is equation 3 and equation 4. Okay, we can decide to use simple substitution method. So I'm going to make use of substitution method here from equation 3. I'm making n subject of the formula. 2m minus n is equal to 0. That means 2m is equal to n. So n equals 2m. And if you are using the substitution method, remember, you simply have to what? Make one of the letters the subject of the formula. And that's what I've done here. So now I will substitute 2m for n in equation 4. I can't take it back to equation 3 again because that's where I got n. So you have to take the result to the next equation. So equation 4 says n minus 2m equals 4. M now, n is 2m. Alright, so what we have here now, okay, we adjust that. So this is saying 2m minus 2m equals 4. So if 2m minus 2m is equal to 4, that is invalid. Okay, so one thing I want us to do, okay, just readjust this. Let's make, instead of this 0 here, okay, instead of 0, okay, let me just leave this as 0. You can change this one here, this minus to plus. Okay, so please, in case you have some people who might have been arguing, there's no solution there, there's no solution there. Okay, I've seen that here now. So you can correct this. So that means I'll come back here to change this to a plus, this one to, okay, to a plus here. So this is going to be a plus. Alright, so this now will give us 4m equals 4, and so m can be equal to 1. This is what we talk about mathematics. I don't get notes and then write all of these questions out. Okay, we are here to learn together for you to see that there's nothing difficult in mathematics. Alright, so we have m equals 1. So if m is equal to 1, we recall that n is equal to 2m. So now that m is 1, so this will mean 2 times 1. And okay, let me use this. We can say n is equal to 2. So in conclusion, x is okay, x is here. X is equal to 6 to number 1 over 5. Y is 4 over 5. 4 over 5. And m is 1. N is 2. Okay, so that is the solution to the question. All right, so now what do we want to discuss today quickly. We just want to look at the types of matrices. Types of matrices. Please, should you have any question on this or suggestion, or you notice any correction here, anything wrong, please, you can note apart from the one I corrected, okay, which is the m, changing the plus, the minus sign to plus, just to make sure we have a very good valid equation. So apart from that, if there's any other one, please let me know. Okay, so you can confirm all of these values to be sure if your answers are right. Okay, all the values of x, y, m, n, you can bring them back into this place. Substitute, you should get back this matrix. All right, so let's look at the different matrices we have. We are going to take the matrices one after the other. Okay, so when we discuss a particular topic where we need that, we use it and then look at the type of matrix that can be involved there. Okay, so what are the different types of matrices we have? Number one, we have what is called the the square matrix. Types of matrices. Okay, so we look at the first one now. We call it the square matrix. We know from elementary mathematics, okay, that a square is a plane shape having four sides, and all the four sides are equal. So when we refer to a matrix as being a square matrix, it simply means all the dimensions, the number of rows, the number of columns, they are equal. All right? So in this case here, a square matrix is a matrix. Okay, this is a matrix having equal number of rows and columns. Equal number of rows and columns. Okay? So if A is a square matrix, then A is written as A n by n. N here represents the number of rows. So you can see now, number of rows, number of columns, they are the same. So when the number of rows and columns of any given matrix, okay, are the same, we can talk about the order of the matrix. So in this case here, that is, A is a matrix of order n. A is a matrix of order n. Alright, so if you have some examples, this is a square matrix. 1, 2, 4, minus 3. This is a square matrix. 2 rows, 2 columns. Okay? We can also have a square matrix like having 3 rows, 3 columns, maybe 1, 0, 1, 1, 0, 1, 0, 0, 1. This is a square matrix also. A square matrix can have as many rows as possible as long as the rows and columns are the same. So I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's very easy to do, okay? So you can see that here. Alright, so when you refer to a matrix as being a square matrix, it simply shows that the number of rows and columns are the same. Now, apart from that, we have what we call the identity matrix. Identity matrix, and this is a special kind of matrix which is very, very important. It has a series of applications also when it comes to learning about matrices. Okay? Alright, so when we talk about the second one, is called the identity matrix. The identity matrix basically is represented as capital I. Okay? So the identity matrix is a square matrix. It is a square matrix, okay, in which the elements on the principal axis. I will tell you what that means. Or principal diagonal. The principal diagonal are ones. Okay? And every other element, okay, is 0. 1, an identity matrix is a square matrix. You must bear that in mind. And number 2, when we say principal diagonal, we mean the diagonal that is formed by the first entry in the matrix. This is matrix A. Okay? I have 1 here, 1 here, 1 here. I'm taking a 3 by 3 matrix here. This is what we refer to as the principal diagonal. Okay? The principal diagonal. Diagonal formed by the first entry. The first entry in this matrix is number 1. Okay, so all these elements here, 1, 1, 1. Okay? So if I have this as 1, 0, every other element here will be 0. 0, 0, 0. So this is called an identity matrix. Okay? So, but don't forget, we represent this as capital I. So I'm going to write this as capital I 3 by 3. If it is capital I 2 by 2, identity matrix of order 2, okay, 1, 0, 0, 1. This is what you have there. It can be identity matrix of order 3, order 4, 4 by 4, 1, 0, 0, 0. Complete the remaining one yourself. Pause the video and complete it. You should get it right. Okay, so if you have done that, now look at this. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, so that is the matrix there. Alright, now there is also what is called the 0 or the null matrix. The 0 or a null matrix. The 0 or a null matrix, if you are to be typing, we denote it by capital letters O. So the 0 or null matrix as well is a square matrix in which all the entries are zeros. A square matrix with all entries being 0. So if I have a 0 matrix of order 2 by 2, this is 0, 0, 0, 0. Okay? Of order 3 by 3, 0, 0, 0, 0, 0, 0, 0, 0, 0. Alright? So we can go on and on also to discuss other types of matrices. Right? So by the time we discuss transpose of a matrix, we will come back to look at what we mean by symmetric and skewed symmetric matrix or anti-symmetric matrix. Okay? After that, when we look at this determinant, we'll come back to discuss what we mean by singular and non-singular matrix or matrices. Alright, so for now, we'll leave it here. So please, if this is your first time of coming in contact with this YouTube channel, this is Program Mathematics. I am Moses Oluwasegun, the tutor on this channel. Please subscribe to this YouTube channel, recommend it to your friends, your relatives, everyone around you. By doing that, you help me to reach out to as many people as possible, and of course, you'll be helping me to make a better life for myself. Thank you so much, and see you in subsequent videos.